Hello students, today we are here to study kinematics, the science of the motions of bodies under the influence of forces or even without them. Today we will study velocities, accelerations, distances travelled and the way various forces affect the motion of several bodies. This science has fascinated some of the greatest thinkers of all time, including Newton and Galileo, and continues to be vitally important today, whether it be in space travel or ordinary motions of bodies. So I would now like to invite Piyush to tell us a bit about kinematics today. Piyush?
काइनेमैटिक्स के बहुत एप्लीकेशन है फ्रॉम डे टू डे लाइफ. प्रोजेक्टाइल्स हम पढ़ेंगे, इसमें रिलेटिव मोशन पढ़ेंगे. बहुत सारे ऐसे टॉपिक्स हैं जो हम आईआईटी के पर्सपेक्टिव से भी बहुत इंपॉर्टेंट है, बिकॉज मैकेनिक्स का पूरा बेसिक ही काइनेमैटिक्स से है. तो सबसे पहले हम काइनेमैटिक्स में कुछ बेसिक इक्वेशन से स्टार्ट करेंगे. जैसे कि हमको पहले पता होना चाहिए v मतलब वेलोसिटी इंडिकेट करता है, r मतलब जो पोजीशन वेक्टर है, और a मतलब एक्सेलरेशन वेक्टर. तो
अच्छा, एक सेकंड. Can you explain exactly what a position vector and an acceleration vector?
ओके, पोजीशन वेक्टर इज जिसका जो टेल है वो ओरिजिन पर हो और जिसका हेड जो ऑब्जेक्ट का लोकेशन है उस पॉइंट पर हो. इट इज अ वेक्टर ज्वाइनिंग ओरिजिन एंड द पॉइंट एट विच द पार्टिकल इज लोकेटेड. एंड एक्सेलरेशन वेक्टर, acceleration tells the rate of change of velocity. So acceleration vector means that it also tells us about the direction and the magnitude of the rate of change of velocity, both along with that. Okay, तो इसलिए हम एवरेज स्पीड और एवरेज वेलोसिटी की बात करेंगे. तो स्पीड, सबसे पहले हम बात करेंगे डिस्टेंस और डिस्प्लेसमेंट में क्या अंतर है. डिस्प्लेसमेंट मतलब होता है कि टोटल चेंज इन पोजीशन. पोजीशन एक वेक्टर है, तो चेंज इन पोजीशन जो है वो भी हमको एक वेक्टर मिलेगा जिसको हम डिस्प्लेसमेंट वेक्टर बोलते हैं. डिस्टेंस जो है वो सिर्फ डिस्टेंस मतलब हम कहते हैं कि कितना पाथ लेंथ हुआ. तो पाथ लेंथ जो है वो कभी हम नहीं कह सकते कि वो नेगेटिव पॉजिटिव है, हमेशा बढ़ता ही जाता है. तो डिस्टेंस ट्रेवल मतलब सिंपली पाथ लेंथ हम कह सकते हैं. तो स्पीड मतलब होता है मैग्नीट्यूड ऑफ वेलोसिटी, और स्पीड जो है वो भी हमें कुछ फर्क नहीं पड़ता, वो नेगेटिव, वो मैग्नीट्यूड जो है वो तो पॉजिटिव ही रहेगा. तो एवरेज स्पीड हो जाएगा टोटल डिस्टेंस ट्रेवल्ड अपॉन टोटल टाइम टेकन.
अच्छा, तो इधर in these formulae, v equal to dr by dt and a equal to dv by dt, these are formulae for instantaneous velocity and instantaneous
yes,
acceleration.
these are only for instantaneous velocity and instantaneous acceleration. Like these are the for non-uniform, we don't know what at the particular instant we are talking about. At particular instant, what is the velocity? Instantaneous velocity and acceleration. And now we are talking about average values. So average velocity is equal to displacement upon time, like I told you. So x2 minus x1, change in position. x2 is the final position vector, x2 is the initial position vector, and t is the total time taken. And similarly, we can find average acceleration, which is equal to change in velocity upon time. Change in velocity is final velocity minus initial velocity upon time. Okay, so delta x is equal to integral of v dt. इसका मतलब अगर मैं किसी स्मॉल टाइम की बात करता हूँ, मतलब अगर मुझे चाहिए कि चेंज इन पोजीशन मतलब डिस्प्लेसमेंट क्या है, तो उसको मैं इंटीग्रल ऑफ वी डी टी से भी कह सकता हूँ, जहां पर मैंने इंटरवल डाल दी t1 से t2 टाइम के बीच में. उसी तरह से मैं ये चीज वेलोसिटी के लिए भी कर सकता हूँ. अगर मुझे चेंज इन वेलोसिटी चाहिए तो उसको मैं एरिया अंडर 80 ग्राफ मतलब इंटीग्रल ऑफ ए डी टी अंडर द लिमिट्स t1 to t2 कह सकता हूँ. मतलब इसका जो मैंने दो इक्वेशन लिखी उसका मतलब यही है कि एरिया अंडर 80 ग्राफ्स गिव्स चेंज इन वेलोसिटी और एरिया अंडर वीटी ग्राफ्स गिव्स चेंज इन पोजीशन वेक्टर और सिंपली डिस्प्लेसमेंट ऑफ द पार्टिकल. इसको हम ग्राफ्स वगैरह में यूज करेंगे कैलकुलेशंस के लिए.
Okay, so now we are going to move to studying relative motion. So Piyush, can you tell us exactly what relative motion is?
Relative motion means like considering the motion of body with respect to another body by considering the other body as a reference frame.
Okay.
For example, like we take a common reference frame like ground frame for considering the motion of both the bodies. Now what we are doing is that we are considering the motion of body 1 with respect to body 2, and how? By making the body 2 as the reference frame.
Okay, can you explain briefly what a reference frame is? For some of us may not know.
Okay. Whatever position vector, velocity vector we are finding out, we are finding with respect to a frame. For example, like Okay, I can show you an example. For example, like this is my origin. Okay.
Okay, so
Like whatever I want to say that, for example, if I choose the point origin, then I'm defining the position of the object with respect to that point, with respect to that x and y axis. Now, what I'm doing is that I'm fixing the origin to the second body, and the axis also change because I'm moving the reference frame to that body.
okay.
Okay, that's how. That's the difference. That's
Okay, so you're basically placing the second body at the origin and observing from there.
yes,
everything.
observing from there.
Okay.
So in this case also like we have to understand that in the first case we take the ground frame. In the ground frame, if we take a ground frame and the reference frame, the frame was not moving. Now in this case, like the body is also moving. So at a particular moment, the velocity of A relative to B, that can be found out by VA minus VB, where VA and VB are the vector velocities of both the bodies with respect to ground frame. We have to pick a frame like which is like rest like ground frame. So like that's how we can find the velocity of both A and B.
So basically, we consider the ground frame to be at rest and get the vector subtraction of the two velocities
Yes.
to get the velocity of A
A relative to B.
Okay, is equal to
And,
VA minus VB.
VA minus VB
Okay.
is equal to VAB. Similarly, relative displacement and acceleration we can find out like the change in position of A with respect to change in position of B having a relative
Yeah.
displacement.
By doing the vector subtractions of displacement and acceleration.
Like
Vectors.
RAB will be equal to RA minus RB, and similarly for acceleration. Okay, so now we move to velocity of approach concept. Velocity of approach is defined as the magnitude of velocity with which two particles are approaching each other at a given instant. Basically, velocity of approach means that at any particular moment, for example, I take two bodies.
Okay, so basically, it measures at which velocity two particles are approaching each other at any given point of time. Like
Now, for example, like I can explain this with a diagram. I have two objects. This is object A. This is object B. At the given instant, A is having a velocity VA, and B is having a velocity VB. And this is the line joining. AB is a line joining the two particles. Now, in this case, for example, like if the angles they are making are theta 2 and theta 1, so the component of velocity of A along the line joining AB is VA cos theta 2, and similarly for B it is VB cos theta 1. So what will be the velocity of approach is the speed with which the two particles are approaching each other. Approaching means like coming closer to each other. So it's VA cos theta 2 minus VB cos theta 1, because VB is directed in the direction away from A.
Okay.
And A is directed towards B. So VA cos theta 2 minus VB cos theta 1.
Okay, so since B is moving away from A,
Yes,
so it is subtracted.
they subtracted it.
And because A is moving towards it, it's added.
For example, if both are coming towards each other, then the thing will be VA cos theta 2 plus VB cos theta 1.
Yeah. Okay.
That's the velocity of approach at a given instant. So now I'm talking about the application. Okay, application is like, for example, we are given a situation in which the two particles collide after some time.
Okay.
So in this kind of question, we know that the
Okay, so now we're dealing with
Yes.
some colliding particles.
yes
Alright.
integral of v approach dt from 0 to t is equal to L. Now how this happens is that किसी भी पार्टिकुलर इंस्टेंट पे मान लेते हैं कि जो velocity of approach
Yeah, can you explain this equation? Like what is L, what is...
ओके
Yeah,
L
let's explain.
अब मैं मान लेता हूँ एट टी इज इक्वल टू 0, दोनों के बीच में जो डिस्टेंस है वो L है.
Okay.
ओके सो व्हाट आई एम डूइंग इज मैं मान लेता हूँ किसी भी एक पार्टिकुलर मोमेंट पर जो वेलोसिटी ऑफ अप्रोच है वो VAP है. ओके सो व्हाट हैपन इज दैट अब किसी भी पार्टिकुलर मोमेंट पर जो DL, अगर मैं मान लेता हूँ DL अमाउंट से पास में आ रहे हैं, तो DL इज इक्वल टू व्हाट V approach into dt.
Yes.
Yes. So what I'm doing is that now I know that approach करने का total distance L होना चाहिए.
Okay.
So integral of DL should be equal to integral of VA dt, that is equal to L only.
Yes.
So-
Okay. So you're integrating the
Yes.
instantaneous distance that travel towards each.
Yes.
Okay.
So, like, obviously VAP will be varying. We must know
Okay,
that
yeah,
VAP
yeah.
at a particular instant. So,
That's why you're integrating over
yeah,
the.
that's why I'm integrating over
And
this.
L is the initial distance.
Yes, L is the initial distance. It is a distance at t is equal
Two
to 0.
particles. Yeah,
T is equal to 0. So
Okay,
it is.
okay.
Okay. So another condition is that because the two particles are colliding, we must also have the condition that along the line joining, we take one component. So perpendicular to line joining, we take other component.
Yeah.
For example, it is VA sine theta 2, and this one will be BB sine theta 1.
Yes.
So our requirement will be the total displacement of the body A perpendicular to the line joining A and B,
Okay.
which must be equal to the displacement of body B perpendicular to line joining AB, because the two objects are colliding after time t.
Yes.
So I have this
So if
equation.
they're in the same position, then
Yes.
vertically also they must have traveled
Yes,
the
but
same.
they have the same position. So
Yeah.
if they have the same position, that means obviously the displacement of them perpendicular to line joining the two must be equal,
Yes.
because they are colliding
Yeah,
into
they must
each
have
other.
covered the same
Yeah,
distance.
same distance in the line
Perpendicular to the line joining
Yes.
them. Yes.
So after applying the two conditions, we have these two equations. So like we also deal with some problems later where we use this. So
Okay, let's move on to the next one. An important scenario in kinematics involves the study of constraint equations. So basically we get these equations when certain bodies are constrained or limited to certain kinds of motion because of certain external conditions. So can you tell us a bit more about constraint equations, Piyush?
constraint equations are like additional equations which you require in solving problems. For example, you will study a lot of concepts in later chapters in laws of motion, but there also you have to find additional equations, that is the relation between acceleration of two or more objects. So you find it using constraints. Constraint is like the physical limitations that are imposed on the body. So I will explain it by the help of an example. Okay, so in this case, the plank is moving in the right direction with an acceleration a, and the box is going downwards with the acceleration b, acceleration ab. And the problem here is that the box is where there are two fixed supports, so the box can move only in the vertical direction. So the thing that will happen here is box will move in the vertical direction and the plank will move in the right direction.
Okay. So the box is constrained to move
Move
only
in
in the
but
vertical
only in the vertical direction.
because of the fixed supports.
Only of the fixed supports,
Okay.
and the plank will go in only in the right direction.
Right.
Okay. So I have to find the relation between A and AB. So how will I find it? Let me show you. Okay. So for example, this angle is theta. So
Right.
this angle is also equal to theta. This is 90 minus theta. Now,
Okay.
okay. The condition here is that this is the physical limitation that we're going to use here. The limitation is that the velocity of both box and plank along the normal to the inclined surface of the plank must be same.
Okay.
Okay.
So this sounds pretty interesting. Can you explain this a bit further? Why this condition must hold?
Okay. Now, the box will have certain velocity along the normal to the inclined surface of the plank. Similarly, plank will have some acceleration along the normal to the inclined surface of the plank. Okay. Now,
Right.
the condition is that both should be equal. And why those should be equal? For example, if the acceleration of box is more than the acceleration of plank, then what will happen is that the box जो है वो तो plank में घुस जाएगा अंदर. हाँ, और अगर बॉक्स का जो एक्सेलरेशन है वो along द नॉर्मल प्लैंक के एक्सेलरेशन से कम हो गया, फिर तो कांटेक्ट लूज कर देगा.
हाँ.
तो इधर ये कंडीशन होना ही चाहिए कि बिकॉज दोनों रिजिड बॉडी से तो अंदर नहीं घुस सकता, कांटेक्ट लूज नहीं करेगा. तो सिर्फ यही कंडीशन है कि दोनों का इक्वल ही होना चाहिए.
Okay.
दोनों का एक्सेलरेशन जो along the normal.
So for these two rigid bodies to stay in contact,
Yes.
this condition holds.
Yes,
The
this
velocity of both the box and the plank along the normal to the plank surface must be the same.
Must be the same.
Okay.
Okay, so we're going to just apply this concept here. So what we'll do is that we will find the component of acceleration along the normal to the inclined surface.
Alright.
Okay, so we'll just look at the angles. Like this angle is theta, this angle is 90 minus theta. So this angle is also equal to 90 minus theta. So we will take the component of acceleration along this direction.
Okay.
So what I'm gonna have here is that this angle is 90 minus theta.
Huh.
This is A. So the component along here is A cos 90 minus theta, that is a sin theta,
Yes.
and here it is a cos theta.
It's very easy to get confused here, but you have to remember that this angle is 90 minus theta.
Yes.
Cos 90 minus theta turns to sin theta.
Yes, a lot of students like do silly mistakes in the exam in the final day, like बहुत टेंशन रहती है. But the thing is that बस stay calm, सिर्फ सिंपल concepts लगाने हैं, और इसी तरह से
focus on the basic concepts.
बेसिक concepts. क्वेश्चन इतने डिफिकल्ट नहीं होते हैं, बस स्टेप बाय स्टेप करना है, कोई स्टेप में दिक्कत नहीं होनी चाहिए. ऐसे कि इसका भी एक्सेलरेशन ए बी है. ओके, सो इसी डायग्राम में ड्रॉ कर देते हैं. नीचे की तरफ ए बी है. ओके, सो दिस एंगल इज थीटा, दिस एंगल विल बी 90 माइनस थीटा. ओके, so this angle will be equal to theta. Okay, so the component of AB along this will be equal to what? AB cos theta.
Yes, AB
Okay.
cos theta.
So this is AB cos theta and this is AB sin theta.
Correct.
Okay, so
Correct.
along the normal we have two components, AB cos theta and A sin theta.
Yes.
Both must be equal, so I just write this equation, AB cos theta is equal to A sin theta, and this is the required constant equation.
Alright.
Okay, so we applied the physical limitation, which was this condition, and we obtained the equation, and this equation is called constant equation.
Okay. So from here we can get the relationship between the accelerations of the two bodies.
Yes.
The box and the plank.
Yes, the
Okay.
physical limitation can be lot of variation, like we will also discuss in some problems. So we will know other physical limitations that can be imposed. Okay, so we studied relative motion before, so we are gonna have application of that.
Alright.
Okay.
So we're
These
going
are
to
very
apply some cases of relative velocity.
Yes.
With some problems.
Yes, this is a very famous case, river problems. Like they are asked almost every time, like when there a problem on relative motion.
It's a very common question.
Yes, if a problem is on only on relative motion, then it is mostly about river problems. And ये concept से दूसरे problems भी हो जाएंगे. So the concept is that हम velocity of boat in still water मतलब velocity of boat with respect to river flow.
Alright.
Okay, this is a simple thing, and so velocity of boat with respect to ground is equal to velocity of boat with respect to river flow plus velocity of river flow.
Alright.
Why is
so
that?
The river has a velocity of its own. And
Yes.
Okay, the velocity of the boat in still water means that it is assumed to be at rest with respect to the river.
Yes.
Alright.
I mean, because in the question the velocity of boat will be given with respect to river flow, and the term that used is that velocity of boat in still water. That the term means that velocity, relative velocity simply. So we obtain the actual velocity by adding the relative velocity and the velocity of river flow.
Alright. Which
Okay.
gives us the velocity with respect to the ground.
Yes.
Okay.
Because like VBR, so VB minus VR will cancel. So like, okay, so we have taking condition here. This is the river. Okay. River water is flowing in the right direction with velocity VBR.
Alright.
Okay. And the velocity of boat with respect to river is VBR vector.
Alright.
Okay, so like this is a point A, I have to reach this bank. Okay, so what is the condition is that the actual velocity of the boat with respect to ground will be this.
Alright, so we add up the two velocities.
Yes, or using triangle law, vector addition, simple. So this is the VB vector, which is the velocity of boat with respect to ground, and that is the velocity that will take us to the other bank.
Alright.
Okay, so what I'm going to do is now is that I'm going to take the components in two direction. Like if this is x-axis, if this is the y-axis, because we're not going to do like put the two vectors there and then add the vectors. We will take the components in two direction and then add two vectors, and that's the best method to add two vectors.
Correct.
Okay, so what we have is that VB vector is equal to VBR plus VR. Now what we will do is that we will take the components of the two vectors in the x and y axis,
Correct.
and by that, if the magnitude of VBR vector is VBR only, okay, then VBR, if this angle is theta, for suppose, then VBR cos theta
Alright. Is a
plus,
component in the
yes, plus VR I cap, okay, plus VBR sin theta J cap.
Right.
This is
So-
the velocity of the boat with respect to the ground. So this is the actual velocity that we have to deal in the problem. and that will help
So we
us to
just
solve.
added the components of the
Yes.
two velocities.
It's in the two directions.
Yeah.
So
In the two directions.
this concept will help us in solving many problems that we'll deal later.
Alright, so this is a generic solution that should be at the tips of your fingers, basically.
Yes,
You
this
should
is,
have
a
quick access
this
to
is
it.
a simple thing that you have to start with in doing this kind of. Because
Yeah.
questions are very easy. That you should use this concept only, that the velocity of boat in still water means velocity of boat with respect to river flow. The simple thing, and that because like some students what they do, velocity of boat in still water they take as a velocity of boat with respect to ground.
Yeah.
That's not the case. So
Right.
you have to like
Still water means with respect to the river flow.
with respect to river flow. Yes. Oh, okay.
Alright.
Okay.